Standard deviation is just basically a measurement of how close together a recorded series of measurements are. So let's give an example, shall we? So let's say you were measuring the length of pieces of wood. Like you worked in a sawmill and you're desperately trying to cut 2x4s and you want them all to be 2 feet long. So you're measuring them and you find out that one is 2 feet, one is 2.1 feet, one is 1.9, one is 1.8, and one is 4.3 feet long. Well, obviously, that is going to be a problem, right? What do we call a measurement that seems way out of whack with all the others?
An outlier.
Yeah, an outlier. So we can't really just toss this out without first determining what the deviation in our error is. So the first thing we need to do is measure the mean. So basically we just add them all together. 2 plus 2.1 plus 1.9 plus 1.8 plus 4.3 divided by 5. So we get an average of 2.42 feet. So that's our mean. Now to determine the standard deviation, we need to see how far each one of our measurements deviates from the mean. So basically what we're going to do is just subtract each one of these numbers from the mean, and we're going to determine what the deviation is. So that would be 2.42 minus 2.0, 2.1 minus 2.42 minus 2.1, and so on and so on. 2.24 minus 1.9. So we take each one of those are deviations, okay? We're going to square them, add them all together, divide them by the number of measurements minus 1, and then take the square root of the whole thing. And that will give us the standard deviation. Okay, does that seem straightforward?
It might to you. Could you just one more time briefly the
Sure.
order of the operation? Not the whole thing, but like
Sure.
Just this last part, the order.
All right, so we find what the average is. We found it here, our average is 2.42. So our mean is 2.42. So we want to know what when we say standard deviation, we want to see basically how big the deviation of each one of those measurements are. And the standard deviation is more or less what the average deviation is for each one of the measurements. So we're going to take we're going to calculate each deviation, which is just whatever the measurement is minus the mean. So we've got measurement 1, 2, 3, 4, 5. We're going to determine each one separately. So 2.42 minus 2. We're going to take the square of that. And to that, we're also going to add 2.42 minus 2.1 and take the square of that, plus 2.42 minus 1.9 and take the square of that. And the same thing for 1.8 and 4.3. Then we're going to add those all together, divide by the total number of measurements minus 1. So we've had 5 measurements, so we divide by 4. And then take the square root of that. And that gives us our standard deviation.
Jesus.
So once we get our standard deviation, we could then use that to determine which one is an outlier. Generally, an outlier has the greatest deviation from the standard deviation. There's no hard and fast rules to what an outlier is. Generally, it's more than the standard deviation, sometimes more than 1.5 times the standard deviation.
Because that's like the perimeter, like the high and low, or like the range.
Right. Yeah, basically, so that's one of the questions, is it gives you the number of measurements, and it asks you which one is the outlier. Generally, it's going to be the one with the greatest deviation. But there isn't any hard and fast rules to what an outlier is. Like I said, sometimes it's the one with the greatest deviation. Sometimes it is greater than 1.5 standard deviation. Sometimes it's greater than 2 standard deviations. It depends on how many measurements you have. If you have thousands of measurements, you can easily determine which ones are outliers. If you've only got like 3 or 4 measurements, sometimes it's a little harder. Okay, so if you have any questions, ask them now, because then I'm going to send you off to do the quiz. I'll give you like 10 minutes, and then we'll get started. Okay. So could everyone get to Chem 210? I know you've been there already tonight. And it's pre-lab quiz number 2. So 10 minutes. You're all doing it now.
Is there an option to have more time, or is that the?
I don't think so.
Okay.
The pre-lab is under quiz, the quiz section, right?
Yes.
And
it should be number 2.
I'm not seeing it there.
I don't see it.
Hasn't been published yet?
Yeah.
No.
No.
Let me see if. Oh, here we go. Oh, wait a minute.
It's not loading. The quiz.
All right.
I'm not
Should start in a minute. I just published it, so hopefully it will start soon. Is it showing up for people?
Mine says past due.
All right, let me edit it.
Same.
Let me see if I can edit this thing. Okay, so are you seeing it now?
Well, it's so I tried to put in my answer, and it showed me the correct answer, but it won't take any answer from me to be submitted because it says it's already past the time. But it shows us the correct answer.
Oh, great. Oh, well. So no one's able to take it? I mean, it's actually giving you the answers, but it's not.
Now it says due in 2 hours.
I'm taking it right now.
I think mine's working
It
now too.
doesn't say that. Mine's showing me the correct answers and it's not letting me.
Well, then you're having an easier time of it than everyone else.
Well, but it's not letting me submit. It's not accepting any answer. So I put in my answer and I click I click up in the top and it just shows me the correct answer and that's it. I don't know if it's possible for me to share my screen with you.
Yeah, let me see. Okay, let me. Yeah, go ahead. So you just hit like enter or something like that?
So it's not letting me submit an answer. It just says time's up and then says your submission, correct answer, but you saw me put something in, right? So like this one, I'm gonna click there and then I'm gonna say, dude, and then it says I didn't submit anything and it says, oh, the correct answer is 3.98.
Go.
Maybe you can retry to refresh your page.
Yeah, because I had the same problem, but all I did was refresh and then it worked.
Okay. Okay. Well, I guess, okay. All right, so.
Yes. So yeah, see if it's working now.
Oh,
It looks like it is.
okay. So.
Oh, get my tea. Be right back.
Oh, sorry. I just realized I'm not muted. Are we supposed to, so we're actually doing experiment 2 tonight?
Yes.
Oh my gosh.
No, I mean, basically it's a do it at home thing. So it should be a fairly short
Okay.
lab. We're just going to go over just basically how to do it and then answer any questions you might have.
So I don't need to worry about like rummaging through my box to get out what I need right this second?
Nope.
Okay.
Although you should have done your rummaging before you got here.
Yeah, yeah, I know.
So is everyone pretty much done at this point?
I am. I'm going to put something in the chat window, Professor. It's because it's an announcement that our lecture professor I just saw about the exam, and it's kind of upsetting to me since I did not finish all of the questions.
Yeah, we were all, yeah, I mean, it didn't quite load on time.
Right. So does that mean that we were shorted the amount of time that we were told we would have to take it, or no?
I think he's still got the same amount of time to finish. I think it was like 75 minutes.
Yeah.
Yeah, so I think there was still 75 minutes to complete it. Is everyone done with the pre-lab?
Yes.
Okay. So just going to go over basically what we're really up to tonight. So one of the most important things you can do when presenting data is to show it in some sort of way that makes sense to people, right? I mean, you can't, if you're trying to figure something out, if you're trying to figure out two things are related, if you're trying to figure out whether one group has the same averages, is the same or different than another group, you need some way to look at that data in a way that makes those comparisons easy to see. For instance, here we've got two, hopefully everyone can see the screen I've got here. You got two different groups of data and two different ways of looking at them. One is if we were looking at just basically a bar graph comparing group A and group B. And we would look at this bar graph down here and we would say, well, there's probably not that much difference between A and B. You see the difference is very small. Then when you looked at group 1 and group 2, if you didn't have those error bars there, for instance, we would just look at it. But actually, they're not error bars. They're basically showing you the range of the data. This is the average of group 1 here. This is the average of group 2. Now, if you just looked at the average and looked at those two, you would say, oh, there's a big difference between group 1 and group 2. Meanwhile, group A and group B, they look practically the same. The difference between those two is very small. So if you didn't do a good job of representing your data, you would come to a mistaken conclusion. Because if we look at the data points up here at the top, this is group 1 and this is group 2. We can see there's a huge spread in that data. It's all over the place. We've got a big difference in the average, in the ages of the people in group 1 and 2. Group 1 has a lot more younger people in it, with a couple of much older. In group 2, they're sort of distributed much differently, but there's so much spread that when you look at the difference, there's actually more of a statistical difference between group A. There's more of a difference between these two groups than those two groups. It may seem bizarre, but it's the truth, because you can see that almost all of group A is smaller than group B, almost all of them. Meanwhile, there's a lot of, in between group 1 and group 2, there's a lot of similarities. And the only differences are really out here in these, what we would call outliers. So it's important to be able to show data in a way that makes errors less prevalent. We want to be able to take our measurements, look at them, and be able to make some sort of conclusion based on them. But we can't do it if we don't graph the data properly. So one of the very first things we're going to do is look at this data. They're here. Where do they give it? Oh, page 3. So here's the data they're giving in group 3. And basically, I don't know why it's all lit up like that. But basically what they're doing is they're looking to see if growing wheat plants under different conditions leads to different sizes. And so they've got one wheat plant here, and they're looking at the growth of it over time. So they're looking at the height. This is the height. Man, what is going on with this? So here is the height of each of the plants. They measure them once a week, starting at week 1. And here's the first plant, here's the second one, and here's the third one. And so as they grow over time, and they want to see whether there's a real difference between 1 and 2 and 3. And so which one of these is the independent variable and which one of these is the dependent variable? Can anyone tell me what the difference is there?
The dependent variable, or the independent variable, I think, is the height. What is the other variable? The fertilizer or something? Or?
No, there's two things being measured here. One is the independent variable and the other is the dependent variable.
I see. So maybe one is the type of plant and the other is the height. So
no, if we were to graph these, for instance.
Okay.
So if we were to graph these, what would be graph? What would we actually draw on our graph? Someone want to let me know? What are we going to put on our graph?
XY axis.
Mm-hmm, definitely. So we're going to draw, something's going to go on the x-axis and something's going to go on the y-axis. What are we going to put on the x and what are we going to put on the y?
The dependent variable is going to go on the x-axis, I think.
Other way around.
Okay.
That is confusing. I must say that is one of the, that is a confusing thing. So we're to plot these things on an X, Y, which is going to go on the X. So the independent variable goes on the X, the dependent variable goes on the Y. Which is independent and which is dependent?
The week is independent, I think.
Which the wheat, or what are we
The
actually
week.
what are we actually plotting? We're plotting two things. What are we actually going to plot? Two things, because remember, when you plot something, you're plotting two things that are changing. So the wheat plant, the number isn't changing. We're not going to plot wheat plant 1,
Oh, I said
2,
the
and
week,
3.
like the week number.
What are the numbers though? What are we looking at?
1 through 8.
That's,
Yeah,
oh, the week.
yeah.
I'm
the
sorry.
week.
Wheat and week sound very similar. So the week is going to be on which axis, X or Y?
The X.
That's right. That is the independent variable. The independent variable is the one that we can independently vary. And so I can decide that maybe I want to measure the height of the week, Now listen, I'm doing it. The height of the wheat in a week and a half, or 2.5 weeks, or 3 3/4 weeks. I can decide to measure whenever I want. The thing that I cannot change is the height. That is dependent on the amount of time. So that's why we call that the dependent variable, because that is completely dependent on how long it's been growing, right? So if I let it grow for 2 weeks, it's going to be this high. If I let it grow for 4 weeks, it's going to be this high. 5 weeks, it's going to be this high. So it's the time that it grows that is dependent on the time it's been allowed to grow. I mean, sorry, the height of the plant is dependent on the amount of time I let it grow. So the x-axis is the time that I can vary. The height is what is the result of the time it's been growing. That's dependent. So we would put the time on the x-axis and, right, the height on the y. So how are we going to, since we have 3 different plants, how are we going to deal with that? Do we want, because we want to compare them.
Probably a box plot graph.
Well,
Or, yeah.
so we're going to plot them basically like this, right? So it's right in the experiment. So we want to plot the time on the x-axis and the height on the y-axis. Now, one thing I want to point out here, because it's a common issue that I find students when they're plotting things. So, how many have actually printed out this graph? You don't necessarily have, if you don't have a printer, obviously.
I'm doing it right now.
You don't have to do it, but you can just use a ruler and plot them that way. But one thing I find that a lot of students have problem with, they will only use this part of the graph paper and leave the rest blank. What you want to do is use all of the graph paper, use the whole thing. Don't use so much that you lose some of the plots. But if the last time you measure is 10 weeks, then your x-axis should probably go out to about 11 or 12. And if the maximum height is 10, then your y should go up to like 11 or 12 as well. So use as much as the paper as you possibly can.
Are these considered linear equations?
That's what we're gonna get to. That's what we're gonna get to next. Because yeah, once you've plotted these things, then the idea is, okay, what is the reason? I mean, what's the reason we plot anything? Why do we bother plotting anything at all?
Gather data.
No, we've gathered our data already. We have data. Why do we want to plot it?
Analyze the data.
What are we analyzing?
Like how much change is occurring.
Right. I mean, basically, we want to see when you plot X versus Y, you want to see what the relationship is between X and Y. That's the whole point. So if you get a straight line, then you know that Y is directly related to X. There's a, like you said, a linear relationship between these two. If like for every change in X, Y goes up by 2 times that. So we would have a straight line. Or for every time X changes, Y goes up 4 times that. And you'd have a straight line, but it would be a little steeper. But if you got something that looked like this, or like this, that's not a linear relationship. Something else is happening. Maybe it's related to X squared, or maybe it's related to X to the 3rd power, or maybe it's related to 1 over X. All these, so you'd be able to tell that by the shape of the graph after you plotted everything.
So on the one on the right, would you say that you could say that there's a correlation, but not necessarily like one is affecting the other necessarily, or no?
But you can definitely say one's affecting the other. Yeah, I mean, as the time increases, all the heights increase, except for at the very end, which means maybe the plant has just got to its maximum height. It's just not gonna grow any higher than that. So, but you can definitely see that there's a relationship between the time and the height. There's no doubt about that. The
strength of the relationship, or the strength of the correlation, is that what we're looking at?
Right. You want to be able to see whether it's a linear relationship or something different. So what I would suggest doing is we'll just quickly sort of we'll graph one of these and then have a look and see what everyone did. And then what you want to do is see if you can make a straight line through your data. Like, so what you would do is you would plot your data. So here's our data plotted on here. And then what we do is we want to draw what we see as what's called a best fit. And a best fit line, maybe all of the points don't fall on the line, but you want to have as many points above the line as below the line, and to have all the points to be as close as the line as possible. So if we were to draw a line like that, it would look something like this. So you see, I've got some points above it, I've got some points below it, and I've got a couple, like 3 right on it. So that would be a pretty good representation of my data that would show you a linear relationship between time and the height. So could everyone go ahead and try, and we'll just draw one of these when you for the actual lab. We want you to draw all 3. So some things to point out when you do that. It's important that we be able to tell the difference between plant 1, plant 2, and plant 3. So you're going to want to have 3 different ways of marking your data points. So if you're going to use all the same color, then maybe I would use one with a circle, one with a check mark, one with an X or something like that. One with like maybe a square. Make sure that they're all different from each other. The other thing you want to do is label your graph. It's really, really important to have the following things on your graph. What are some I'll let you guys tell me. What are some of the important things to have on a graph as far as information goes? What do you want to include on a graph to give as much information to the reader of it as you possibly can?
The number of the the population, the number of plants, or
No, just any graph in general. Just what sort of things do you need to include on a graph? Anyone?
Label the X and Y axis.
There you go. That's what I'm looking for. Yeah, you got to label the X and Y axis. You have to tell me what it is I'm looking at. Because if you just give me a graph with a bunch of dots on it, I have no idea what it is I'm looking at. I'm looking at some dots. Yeah, it looks like there's a relationship between one thing and another thing, but I don't know what those things are. So it's really important you label each of the axes. What's also important about the labeling the axes? So you label them, you say what it is you're plotting. What else is important about labeling them?
your unit of measure.
Yes, critical. Very, very important. You got to have the units there. Just like when you're making a table, you have to say what the units are. So like when we were our lab last week, we were measuring different things. It's really important that you say what the units are, or length. I don't know what that means. Is it miles, kilometers, inches, centimeters? I don't know. So you have to tell me. So here we have centimeters and here we have weeks. Okay, that's important. What else do I need to include in a plot?
The title.
Yeah, big time. Exactly. What am I looking at? Yeah, I know something's a different height over time, but what am I looking at? I don't know. Is it a wheat plant? Is it a plant? Is it a slug? I don't know what it is I'm looking at. So really important, exactly, to have the title. Excellent. And what about this one? What's important? There's something else that's on the second plot that isn't on the first that I need to know.
The shape.
The outliers.
No, that's
Oh.
no. I mean, that's sort of you can figure that out certainly by looking at it. But if you're drawing the plot, you need to tell me something that I can't figure out for myself. So I see like there's three different bits of data there. I notice that there's circles, there's diamonds, and there's X's. What do you need to tell me about those things?
Oh, like a legend.
A legend. Excellent. Yeah, even got the term right. Yeah, a legend. I don't know what those are. Are those three different wheat plants? Are they the same wheat plant grown under different conditions? I don't know what they are. So you would have that in the legend, and that's what this is. And sometimes you'd have the legend outside the plot. Sometimes you can have it inside the plot. So why don't we go ahead? Right. So why don't we just go ahead and quickly draw like for plant number 1, and then we'll see what people have. Okay. Just take a few minutes. So you can see on the plot they give you, there's a space for a title, there's a space for the y-axis title and the x-axis title. The other thing, like I mentioned, I would recommend is use as much of the space as possible. So yeah, go out and also make sure you have the same space in between. So you can't have like 3 spaces between 1 and 2, and then 4 spaces between 2 and 3. Yeah.
Professor, are we allowed to use, I'm reading this here and it says computer graphic. Are we allowed to use like StatCrunch?
You can use whatever statistical program you want. I was going to basically show you how to use Excel and Google Docs, but if you got something better, and believe me, pretty much anything would be better than either of those, feel free to use it.
I have a license for StatCrunch because I took statistics last semester.
Oh, then use that. Yeah, by all means. No, we're not telling you which ones to use. These are just like the usual ones. But if you have something better, and like I said, pretty much anything would be, go ahead and use them. Oh, I need to get to work on my plot here. So remember, we're just going to do wheat plant number 1. All right, so this is what I got. Hopefully everyone's got something sort of looks like that. Can I have a look at some? Can I have a look at some of yours?
I'm still working on.
Yeah, whatever's finished, just hold it up to your camera. Let me have a look at it, see if I can actually see something. Just want to get an idea of how people are doing this.
I can share my
Oh,
screen.
oh, there you go. There you go. Excellent. Oh, you did all 3, man.
I did it like earlier today.
Oh, very good. There you go. What do you showed us here?
Do you see the graph or no?
I do. I don't know what I'm. Why are there points at like 15?
Oh, okay. All right. So like
This is supposed to be by hand. The first one. The next ones are computer.
Okay.
Yeah. So anybody else have one done?
Well, we can't do them by hand unless we've printed it out, I guess.
Or you could just draw it on paper with a ruler. That works too. Only doing, yeah, plant number one, wheat plant number one. And then for the actual lab that you submit, they want both, like all 3 wheat plants and then all 3 rye plants on separate graphs. For tonight, I just want to like to see what how you're dealing with just doing one. Yeah, you could use different colors. Like if you have colored pencils, that's a really good way to do them, because then, you know, it's really obvious which is which. And color is always nice to have in graphs, especially when you're drawing lines through them. Does anybody else want to proudly show me your craftsmanship? Or everyone's tired, they've had a test and they just want to go to bed. I can certainly understand that. Brandon, show me what you got. You've got a background on, so all I can see is the Golden Gate. It looks like you're holding up the Golden Gate Bridge. You have to turn your background off, man. I can't see this. There you go. Perfect. Excellent. Right. So when you draw this, like I said, what you want to do is also do a best fit straight line through them, sort of like I showed previously. Still need to label those graphs, label the axes, Ruby. And so a best fit straight line would sort of look something like that, as I showed you. So you can see it's not perfect, and these things are rarely going to be perfect, but you can see that there's points on the line, there's points above the line, and points below the line. And they're all really close. So if you were looking at that, you'd say, well, that's probably a fairly good representation of a linear relationship between those two. So now we're going to look at how do we actually determine what the relationship is between them. And then that means we're actually going to have to plot them. Oh, Angsuma.
See that? Or
Excellent.
okay.
Very nice. Yep. So it seems like we've got that one down. Oh yeah, we can have all 3 wheat plant. Yeah, in fact, that's the whole idea, is to have all 3 on there, because you want to be able to compare them. And that's the other point of having a plot. Not only do we want to see the relationship between the time and the height, we want to see whether each of them is the same. We want to see whether 1 and 2 and 3 are the same or whether they're different. And so having them all in the same plot at the same time gives us an easy way to sort of visually see whether or not that's the case. So yeah, definitely have them all in the same, and then on the same plot. And then remember to include telling us which is 1, which is 2, and which is 3. So what I'm going to do is, who has got Excel and who has Google? Well, everyone should have access to Google Sheets or Google Docs. Does anybody have Excel? So I think you actually have, maybe this isn't true this term, but I think.
Excel, but I mean, I don't plan on using that for this, but I have it on my computer.
Right. Well, okay. Who's planning on using Excel? Can I get like a show of hands or something?
I just downloaded the Excel one for the graphing tonight.
Okay.
Pretty helpful if that's what you mean. You're talking about the graphing
Right.
Excel Word thing. Right? Yeah, it's really nice.
Yeah. I think you have, I think as students at Skyline, I think you have free access to Microsoft Office. I think, at least that has been the case in the past. I don't know if it's still true, but I think you do. I'll try and find that out for you if you haven't got it already.
I think every student, if you use like your SMCCD email, gets
Right.
Microsoft
Yeah.
Office.
Exactly. Yeah. So you have the option of using it, and I mean, Word is pretty much essential. You got to have that, but and PowerPoint is great to have. But yeah, Excel. Some people like it. Some people hate it.
Sorry. Does it work for Mac too, the Microsoft?
Mm-hmm. Yep.
Oh, okay. Because I just know it's when you buy it, Mac is always a little more expensive because of OS or whatever.
But well, ask the bookstore. Yeah. So using your email, was that the Windows version or the Mac version or both?
I think it was the Mac version for me.
Yeah, I think it's either one because because so many students have Macs because of the educational discount that I think it's for either one. So if you have, who's going to be using Excel? Just give me like a thumbs up or something. I'm just wondering whether we should bother using Excel or whether we should just show you how to use Google Docs. Two people going to be using Excel.
I mean, but but we can use like StatCrunch if we have StatCrunch.
You can
right?
use whatever you like, but I don't have StatCrunch, so I can't demonstrate how to use that. Okay, I might as well just I'll take you through Excel and then briefly through Google Docs or Google Sheets. There's also I put on the Canvas page. The other instructor, the other lab instructor, posted a really nice video, basically taking you through both of those. So if you fall asleep because of my dulcet tones, or you just want to go home, or just go to bed, you can watch that. So you can watch that one any time. It's very, very, very helpful. So what I'll do is go to Excel and take you through that, and then we'll go and quickly look at the Google Docs. So let's look at Excel. Where is my Excel? Here we go. Hopefully, so can people see it? People see the Excel screen?
Yeah.
Okay. So we just type in what are all the data goes in here. And then we want to be able, we just label which is which. And so this part is, pretty much straightforward. So when we want to plot these, we just select without selecting the words, the letters. We just select the numbers. Everyone knows how to do that, how to drag across, hopefully. Took me a while to learn how to do that. And we go to insert. So what this means is we want to insert a table or a graph. And so we want to take these numbers and then insert on the other side a table or a graph or something. So we just say insert, and then this pops up, and then there's all these different things we can do bar graphs, we can do maps, we can do different sorts of charts, pie charts, bar graphs, all that kind of stuff. What we want to do here is a scatter plot. And a scatter plot is just basically what we've been is this. It's just all the data directly plotted on an XY axis. So we'll select that and say, do we want lines drawn through them or not lines drawn through them? Right now, we don't want any lines drawn through them because we're going to look at it and see what kind of lines we want drawn through it. So we just select this first one. And then I think I'll make it a little bit bigger to make it easier to see. So I'll just, all right, so make it a little bit bigger so I can see all my data. And here we can change the chart title. We can just click on that. And so say I want wheat plants time versus height. So there's my title. And then move this over. Then I want to start looking at my data and seeing what the relationships are. And so I just basically click on them. So I click on this point right here. And you see how basically it lights up all of the points in that particular line. And it also lights it up over here because it shows you that's plant number 1. So all of these that are lit up are plant number 1. So I click on this plus sign and it says, what do you want to add to the plot? Well, I want to add axis titles. I want to have, you always want to label your axes. So I want that. I also want a trend line. I want some sort of line that connects all those points and tells me what the trend is. Is it linear? Is it exponential? Is it logarithmic? I mean, I don't know. Looks like basically looking at the graph we drew ourselves, it looks like linear is probably a pretty good fit. So I go to trend line, I click on that, and I say trend line for series 1, and it gives me a linear line all the way through. Then I want to do the same, but I also want to know what that relationship is. Yeah, I can see there's a line there, but I want to know what the relationship is between my time and my height. So while I can also change my title down here. We're going to make that time in weeks. I can change this to height in centimeters. Now I want to see what that relationship is. So I'm just going to click on that again. Oh, wait a minute. Linear. And then what are my options for that? So my options are, do I want an exponential, linear, logarithmic? I want linear, and I scroll down. I want to display the equation because I want to see, well, what is the relationship? So I just click on that, and you can see that this shows up. So this is my relationship for plant number 1. My relationship is y, which is the height, is related to x, which is the time. For every week, it seems that the height increases by 1.238. So this is our classic, where's my annotation? Here we go. So that is my y equals mx plus b. This is what a linear graph is going to look like. So anyone tell me what the m and the b are? What is the m and what is the b?
The N is the sample size, so the number of plants.
Slope.
The slope, right. M is the slope.
Is B the y-intercept?
And B is the y-intercept, exactly. So you can see that if we continued this line, it would intercept the y-axis at around 1. So basically what it's saying that at 0 time, the plant was 1 centimeter tall. Now this is a sort of a tricky proposition because I don't know whether that plant was 1 centimeter tall at time 0, because I don't know whether these people planted seedlings or whether they planted seeds or whether they started measuring when the seed germinated. I don't know any of that. So we're going to learn that we can force Excel to give me a spot at 0, 0. But I don't know whether or not that's the right thing to do. Okay, so we're going to learn how to do that, but I want to tell you, based on the data we see, we don't know what height the plants were. We can sort of guess because you can see plant number 3 was 0 at 1 week. So maybe they did, plant seeds and just looked at the height. So I don't really know. So we're going to learn how to do it both ways, how to force the line to go through 0, 0 because it should, or we just leave it like this. So let me clear this. So the other thing we can, oh, wait a minute, where's my mouse? Here we go. So this is our trend line here. The other thing we would want to look at is where's our plot line? Okay. There we go. The other thing we might want to look at is we have the equation. We also would want to see what the r squared is. Anyone know what the r squared means? Who's done like statistics, or well, I know Ruby has. Anyone else taken statistics or done any sort of like plotting before?
I did stats last semester,
Mm-hmm.
but I don't know.
Did they mention r squared?
Yeah, but that's not the correlation? No.
No, it is. It is. It's
Oh,
it's called linear regression. It's a regression, and what it is, basically it takes the same thing we did before in figuring out what the standard deviation was. So remember, we were looking at the standard deviation, which is either sigma or s. That gives you an idea of how close together all the points are, how much scatter there is. Well, the linear regression shows you basically the same kind of thing. It says how far are these points off of the line. So these are our points. Actually, it's the blue ones. Duh. It's the blue ones. It shows you how far the points are off the line. And if they're all exactly on the line, our r squared would be equal to 1, which is a perfect, so 1 is a perfect correlation between x and y without any variation. Now you can see here our r squared is 0.975, which is excellent. Basically anything with an r squared better than 0.9 is considered good. I mean, we could consider that's a linear relationship, or whatever relationship, if it's like this or like this, whatever equation we're fitting to that line, or r squared is better than 0.9, then that's probably the right equation to use. So in this instance, we've picked linear, and that's the right equation to use. So let me clear some of this. So now, so that's number 1. So we'll move these two together. So we put them together. Yep. Now let's look at plot number 2. So now I'm going to do my second one. So when I click on the second one, you can see that wheat number 2 now lights up. And I just do the same thing for that one.
I just wanted to tell everyone about this applet that you can use to do these calculations. It's a free applet, and I put it in the chat window. It'll calculate the least square regression line based on what you put in.
Okay. Yeah, I mean, you're not stuck with using either of these. We'll accept, anything.
Oh no, I mean this is just like a tool. It's not a graphing program or anything. It'll just so that you don't have to do the calculation by hand, it's free.
All right, so here's our trend line for number 2, and we just do the same thing. I want to display the equation and display the r squared. Wait a minute, why am I getting, oh, wait a minute, I want series number 2. All right, let's try that again. All right, so number 2, I want number 2, wheat number 2, there we go. More options, series 2, there we go. So I want my equation, r squared. So here, I'll move this over. So here's my number 2. And you can see that, so now my relationship is slightly different. The slope isn't quite as high. It's now y equals 1.06. So it's not quite as steep as plant number 1. And the y-intercept is closer to 2. So the y-intercept comes down to about there. So 1.6 for group number 2. But you can also see that the r squared is also excellent, 0.98. So that's even better it's even better fit than the first one. So that's good news. And then let's finally do the last one. So I just click on this one. This is series 3. So I make sure that series 3 lights up over here. That's important to make sure that when that lights up, that tells you you're looking at the right set of numbers. So number 3, I want, number 3, I want the trend line for number 3.
Sorry, Professor, did you say that this program has been tailored to do this assignment?
No, it's just that a lot of people have it. A lot of people have Microsoft Office, and so if they have Office, they have this to use.
And where do we get that from?
I think you can get it from the bookstore, right? Is that where you get using your? I think is it where did you find the free Office download? It's on Is it on the?
Oh no, I mean this is like a template or something, isn't it, that you've got loaded?
No, it's just Excel.
Oh. Okay.
No, we just typed in the data, that part, and then this is all just. No, this isn't any special template or anything.
Oh, okay. You made the legend and all of this stuff yourself.
Yeah, we just did that. Okay. So just do linear, more options, for that one. So we want linear. We check and make sure it's series 3. Display the equation and display the r squared. So here is the third one here. So I'll just move it down here. So you can see that this one has the lowest r squared of the 3. And that's probably because we've got 3 points that didn't change at the end. So like at week 6, week 7, and week 8, the height didn't change. And so that's obviously going to throw off the fit, because one of these is directly on the line and the other 2 aren't. So that's going to throw off the fit somewhat. But it's still better than 0.9. So it's probably a linear relationship between the two. There's always, like we've been talking about, there's always going to be some error in any sort of experiment you do. Maybe they forgot to water it. Maybe it was cloudy for a day. Maybe a lot of different things could happen. But you can still see that it is linear. So what you might want to do is mark which one is. You put them in different colors. You could change the color of each one of these, or you could change the font or something to let you know that this one is series 1, this one's series 2, this one's series 3. I think you can even type. You can even type in there. So that would be plant 1. So you can just put it like that. So just basically show us what the relationships are and how good the correlation is. Now, one of the questions in the lab handout was, what if you want to force the plot to go through 0? So what if you force the y-intercept to be 0, basically? And you can do that in Excel. We're not quite sure how to do it in Google Docs yet, but in Excel we do that here. So let me show you how that works. So I'm just going to show you for the series 3 here. So I click on it. Series.
Is this all your sessions are all recorded, right?
Yep.
Okay.
Series 3. Oh, series 3 trend line. Here we go. So we get to the trend line options, and yeah, believe me, that's why I don't like Excel that much, because it takes you a while to dig through all these sub menus. But down here, you can see there's a little spot that says set intercept. Basically, what you're saying is, I'm going to force the intercept to be 0 and 0. So x equals 0, y equals 0. So 0, 0. Then display what that equation looks like. You can see it will change. And you can see the slope of the line is now different. See, it's changed a little bit. See how, oops. The first time we drew it, the line was here, and the second time we drew it, the line is there. When we extend it, it goes right through 0. So we want you to be able to show what the change is in the slope after you've done that. And the other thing to notice is notice now sorry, I'm not an expert with this, as you can probably tell. Notice now there's no, damn it, there's no y-intercept. So here's our first one, the first time we plotted it, and here's the second time we plotted it. Notice there's no y-intercept. There's no plus b because it goes through 0. So that's how we can tell, that's how we can tell the difference. So notice now, actually our R squared is better than it was before. So it's actually a better fit for the line that it goes right through 0. So our slope has changed slightly. It's got closer to 1, and the R squared is a better fit. So you can see that's probably not a bad idea to do with that one. To do the same thing for the other two. I know you probably got lots and lots of questions. Who's got some, I'll check who's got some questions about how to use Excel? I'm sure there's a ton of them.
There's also the Desmos is the graphing calculator. That's a free tool online as well that
Yeah.
we'll get.
Yeah, someone told me about Desmos today, actually. I haven't had a chance to really look at it yet, but yeah. All right, so that's Excel. And let's just quickly go to Google Docs. It'll be very, very similar. Not exactly the same, but quite similar. So let's.
I just have to say that somebody that is a beginner in Excel or not used it very much, this is really advanced.
Yeah, I mean it's basically, I mean, this is like what you want to use Excel for, is to plot something and then and then fit the data to a line, either linear or logarithmic or exponential or something. That's basically the whole point, is to show you what the relationship is between X and Y. So if there's an easier way if you have a way of doing it that's easier, and I imagine there are lots of them, then yeah, I would recommend that. I mean, because for instance, I've been using Excel for like 30 years now, and I still don't like using it. There are a lot of other programs that I've used that I like a lot better than this, but it's basically because it's designed by engineers. So engineers like to do everything more difficult than it needs to be. Not that I'm sure some of you will make lovely engineers someday, but I don't know. I can't cope. So let's look at okay. So now we're on Google Docs. Hopefully everyone can see. So everyone has access to this. Everyone has a Google account, I'm sure. And so what you want here is Google Sheets in particular. And you can see that the data is we put it just exactly the same as we did for Excel. Week, wheat, the whole thing. And we plot it the same way too. So we just select and insert chart, and then boom, it automatically does that for us. And then we can make this larger or smaller. So you can see that it's not quite as nice as Excel. We don't have quite as many lines on it or anything, but it does do a pretty good job of doing it quickly for us. Now, getting the lines on it is a little trickier. So when this is open, this little chart editor pops up, and we can customize what it is we're looking at. We can put titles, so we can type in, it already has given us a chart title, but we can change it to whatever we want. Wheat plants height over time, something like that. And it goes right in there. You can change the fonts and all that kind of stuff. What we really want is, oh, and we can change the axes. We can like label the axes right here. So where is it? So label it. Here's our label. Oh, I think we just click on it to change the label. So what we want to do is find the lines, the relationships between them. So we want to come down here to grid line. Oh, sorry. Click on my point. Where is my trend line? Oh, here, right. Select data. Where is my trend line? Is here somewhere. Damn it! I knew I knew where it was this afternoon. Data. Where is our trend line? Damn it. Trend line. God, there it is. You can see they don't make these things easy. Yeah, so you go to series and then trend line. There we go. So it gives you linear. You can choose what kind you want. Here, there's a number of different ones. We want linear again. Show the R squared. We also want to see the equation, please. That's not it. How do we see the, oh, label, use equation. Duh, there we go. Yeah, so label, use equation, and show the R squared. And just do the same thing for the other two. So select that one, series. We want the trend line. We want the R squared, and we want the equation. And the same with the first group. We want trend line, and we want the label of the equation. So now we have all three. But you can see one problem we have is we can't really see all of the data. Notice that some of these data points are kind of lost. And so we can go back and set up our y-axis, or we can change our y-axis. So horizontal axis. Here we go. So minimum value, right now it's set at, put it at -1. And say 12. And then do the same thing with the vertical. Vertical axis. -1, 12. That way we get to see all of the, all of the data this way. We don't lose anything. And then finally put in the, change the axes, the week, put in the week, the time, and the height. And so if you're going to use this, and then it asks you to force it to go through 0, I think the best thing I would recommend is then just adding one more point for week 0. Add just one more point. Have week 0, wheat number 1, wheat number 2, and wheat number 3 all be 0, and plot that. So then compare the plot with zeros there and without, and see what your data looks any different. So I know this is a little confusing and a lot to lay on you, but basically this is how you're going to do this particular experiment. It's just about plotting. You'll have the video to look at. Both the other teacher has put one on here, and I'm going to post this tomorrow morning, so you'll be able to review it. Probably got lots of questions, and you're also very tired. So, who's got some questions before we wrap things up?
I know I've asked this like 3 times already. I just want to one more time reiterate: we can use whatever graph.
Whatever you want.
Yeah. Okay. Good.
Yeah. Yeah, if you have a better, like I said, Excel and Google Sheets, it takes a while, as you can see. I mean, it takes a while to get comfortable with these. If you have something that you've already used that you're more comfortable with, use that. It really doesn't matter. Anything that can show a plot with a slope and a y-intercept and an r-squared, that's fine. I don't care what it is. Any data analysis program you have, feel free to use it. The more the merrier. Just make sure that the plots are legible, that you have legend in there to tell us which is group 1, group 2, and group 3, and what are the slopes and the y-intercepts. That's basically all we're interested in here.
Just FYI, Professor, the experiment meant like the instructions do tell us to do a hand-drawn one, but I mean, I'm not going to, but I just wanted to let you know that is what it tells people to do.
Mm-hmm. But you're not going to do that?
Well, no, because I mean, or do we need to do a hand-drawn? I thought we were doing this. This is not hand-drawn.
Yeah, we're doing both.
Hand drawn
Oh.
in the first.
Oh, we're doing both. Okay.
Yeah, doing both.
Oh, okay. Shoot. Okay.
Yeah. But yeah, I mean, the hand-drawn one, you can knock that thing out in, like 10 minutes. You can see it. Look, it took me a lot longer to just remember how to use this damn program. So yeah, it takes a little time to get comfortable with these two. Yes.
So that was my question. If we hand draw and then choose either Excel or Google Docs to do it as well.
Mm-hmm. Right.
Okay, but they're both basically the same thing, right? One is just online and one is hand drawn.
Yeah, I mean, well, the difference in Excel and Google, you should get the same answer. Hopefully, you should get the same slopes and everything else.
And the hand-drawn graph is representing the same thing as the computer generated one. Is
right.
that right?
Right. Yeah, you're just not expected to work out what the slopes and y-intercepts are with those. Let the computer do that. Although, I mean, I'd be kind of curious. I mean, I could see that, you know, the way I've drawn this, I'd be curious. I'm going to go and look at and see whether my y-intercept is close to what the computer predicted it should be. It looks pretty close. So yeah, the y-intercept be pretty easy to tell, but figuring out the slope, that's a lot of work. I'd rather just have the computer do it. So is everyone clear on what's being called for? The hand drawn with the wheat data and the rye data, and then the basically a plot that looks like this.
We're not actually growing the plants, right?
No, that's for later. That would be a biology class. All right. Any other questions before we go? Remember, yeah. And so if you're totally lost, and I could totally understand why you would be, yeah, just come to office hours, or just drop me a note, and we can get together pretty much any time I'm not teaching, and we can go over this one-on-one or with a group. I'm easy to get a hold of. All right. So anything else before we go?
No, thank you.
You're tired. I'm tired. Yeah, it's been a long day. Okay. So yeah. So drop me a line. I'd love to see somebody show up at office hours. I get lonely. So I will see, if I don't see you then, I will see you next week. Okay. And we'll do something a little bit more fun than play with Excel, believe me.
Oh, wait, next week we don't have a lab.
Oh, is it a holiday?
Yeah. So
Ooh.
the following week, yeah.
Okay. Thanks for reminding me.
2 weeks.
All right, cool.
Okay.
All right. Well,
Thank you.
all right. We'll see you later. Have a good night. Get some
You
sleep,
too.
everyone.
Thank
Thank
you.
you.
All right. Bye-bye.
Thank you. Good night.